Okay, guys. When you do this regression, after you watch the the report stat video, how to do this in Excel, you're supposed to get this table in Excel. Three sections for the table. You really pretty much need the first one and the last one. First one gives you two major uh, facts or important features of Excel, the multiple R, which is in this case 0.7113, and the R square value 5059. Table 3 gives you two pieces of information, the intercept, which is 7.1619, and the coefficient next to the education, and this would be the slope. You also see in that same table t-stat and the p-value. We'll talk about this later. Now, from this table, we can figure out that there is a linear equation. As we said earlier, in stats we call it y hat, b0 as your y-intercept, and b1 as your slope times x. Now your y hat, that's your sick days or sick leave. Your intercept would be from this table 7.1619, and the slope is 0.0732, and your x would be hours. So this is the equation that relates sick leave to hours. Now the question is, how strong is this relationship? There are two ways of looking at it. To talk about the strengths of the relationship, you can talk about it from the value of R. Now, the value of R, Excel always gives you the value of R as positive number, but you have to check the slope. If the slope is negative, you have to say your R is negative 7113. Anything in the 70 above range, we consider this somehow strong relationship. So you say two things. Since the value of R is close to 1, hours and sick leave are somehow strongly related. I don't want you to say that they are strongly related or very strongly related. Say somehow, because if it's a 0.8 or a 0.9, you would probably use a stronger language. Now the other thing, the fact that this is negative, and again, we figure it's negative because the slope is negative. So you say, since R is negative, then hours and education are negatively related. I don't know if you can see this. Yeah, they're negatively related. Now, what is negatively related? I'll talk about it here. Let me erase some of this. Yeah. Negatively related means increase in hours will lead to decrease in sick leave. And maybe here you can expand on this a little bit. So basically what we're able to prove at this point that yes, there seems to be a relationship between hours of education and sick leaves, and the relationship is negative. So the more education a worker has, the less likely he or she will actually skip working days. So more hours, less sick leave. So the relationship is negative and somehow strong. You can also see it from here. R squared. The R squared value is 50, 59, and this is actually a percentage, and it's always positive. This one is not a percentage, it's only a number. This means about 50.59% of Y sick leave can be explained by X. Hours. So in statistics, anytime this is more than 50%, we say we're in the good spot. So you can explain more than 50% of the answer. So again, that's an indication that you have somehow a strong relationship between the two. Now, they also can talk about the equation a little bit. Now, this equation, if you think about it, what is this equation good for? Now, I'll take you back to the actual information of the actual report. So in the actual report, if you remember, the number of hours, X, the minimum number was 0, the maximum is 120. So minimum number of hours, X, was 0, and the maximum number of hours, 120. This equation can predict sick leave for any X hours within this range. We call this the regression range, or so like if you say, what's how many sick leave would you have if number of hours were 10? You just plug 10 in the equation and that will tell you the sick leave. 20, 30, 40, 50, just any number between 0 and 120, that's your range. You just plug in the equation and that will predict how many sick leave days you'll have. Anything more than 120, this equation becomes irreliable. You can't really predict when the numbers are more than 120 because that's your range. Now, you can also prove how strong the relationship is using statistics. If you check the formula sheet, there are two formulas for regression or hypothesis regression. There is hypothesis used for correlation, and there is hypothesis for projection. Projection means how good the equation is. So that there are two ways of looking at it. Eventually, both will give you the same answer. The correlation is T core, it's R minus this, 1 minus R squared over SSX. And you'll see this formula, it's in your formula sheet. And there's also the T-slope formula. And they're both in the, I'm not sure if this number is supposed to be SSX or N, but the formulas are in your formula sheet for the T-core and T-slope. In fact, you don't need the actual formula per se, because both will be the same number eventually. So, to do this using hypothesis, whether correlation, you can do it this way. Using hypothesis testing, to see if there is a relation between hours and sick leave, or whether we can use the equation or not. Okay, when you do this hypothesis, you start with, like, H0, HA. And this type of hypothesis testing, H0 would be the no. So you'd say, no, there's no relation, no, we cannot use the equation, and this would be yes, there is an equation, and yes, we can use the equation, yes, there is a relationship. Test, you put T-core or T-slope, because they both give you pretty much the same answer. Now, we're going to do this the p-value approach. And in the p-value approach, it's pretty much standard for all hypotheses. So under decision rule, if your p-value less than or equal alpha, and we're going to use 5%, that's a standard. You can use 1%, 10%, the standard is 5%. Then you would reject H0. So now, you can just jump directly because you have the answer from the report. So in the analysis, you say from the Excel output, you get a T-stat, which is T-core, T-slope, T-stat, and this is the number next to, in the second line in this table. This is the T-stat you need, which is minus 42929, and the p-value you'll see next to it, p-value is 0.0004. So you'll see that your p-value is less than alpha of 5%. This number is way less than 5%, so we're going to reject H0. As we said earlier, anytime you reject H0, you have to mention the type 1 could be committed with risk equals alpha. And if you're rejecting H0, you're accepting HA. So you put the conclusion in English. And the way you put it in English, you say, we have enough information, or we have sufficient information to show that there is a relationship. So now we prove statistically that there is a relationship. So the regression output, again, all you need from it, the r and the r squared, that will tell you how good the relationship is. We figured this is a very good relationship. You also need the equation from it, so we established what the equation is. And you can also test statistically of how strong the relationship. Now we just proved statistically the relationship is very strong. This is what you can do in the analysis, in the conclusion of your report, that yes, a relationship exists and everything, and what we talked about. Good. Now, I will do actually another part to talk about. So after doing this, he wants you to talk about recommendation. He wants to talk about shortcomings, how we can improve this. So I'm going to talk about it in another video. Thanks.